Now, on to page 2 of day 1. We can see 3 more practice problems up here. And guys, this is going to be critical that you see how we do these 3. These are going to be 3 great reminders. And speaking of reminders, remember whenever we had on our last page, the radical in the denominator, we said we have to multiply that by the denominator, and that's true. But we don't want to change this value, or else we're not even dealing with the same number anymore. So we have to multiply by that number on top too, because that is really just 1. We're not really changing this. So 2 times the square root of 3 gives you 2 square root of 3. And the square root of 3 times the square root of 3 is really 3. And so we see there we've got plus or minus 2 square root of 3 over 3. 2 over 3 will not reduce. Here's where we have to be careful. 80 and 192. What perfect square is in them? That's the tricky question. Here's my pro tip. So 80. It needs to be a number, can't be any of these. So starting with 64, work your way down. So starting with the number smaller than 80, start with the biggest and work your way down. Now obviously it's not going to be 64. Not going to be 49. 36 does not go into 80. 25 does not go into 80. How about 16? Here's how you can check. 80 divided by 16. Oop. Boom. 5. That works. So our square root, which is 16, that's our perfect square, can be multiplied 5 times to get 80. And so if that's the case, we then know we can split that into the square root of 16 times the square root of 5. And we know the square root of 16 is going to be plus or minus 4 times the square root of 5. And that is the simplified form of the square root of 80. Same thing as before. I want you to ignore that 3. Let's look at 192. Once again, can't be that, obviously. It's got to be under 192. No, 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 no. Couldn't be 81. I don't know about 64. We can try 64. Let's try it. Start big and work your way down. 3. Boom. That works. So we've got the square root of 64 times 3. 64 being our perfect, oops, don't know why I wrote it there. 64 is our perfect square. So then we know we've got 3 times the square root of 64 times the square root of 3, which then means that we've got 3 times 8. Square root of 64 is 8 times the square root of 3. And 3 times 8 will give you 24 square root of 3. This is critical, guys. Understanding how to find the biggest perfect square. And that's the key. The biggest perfect square. It has to be the biggest. Otherwise, you will continuously break it down. It's like those Russian nesting dolls. You'll keep breaking it down, breaking it down, breaking it down. Now, I'm about to introduce you guys to one of my favorite methods. I call it the SOX method. And if you've had me before, you may have seen this before, the SOX method. This is what we use whenever we have variables underneath the radical. So if you have x, y, z, all that good stuff. When this happens, if the exponent for the variable is even, then you simplify that exponent by dividing it in half. Here's the problem. If the exponent for the variable is odd, you drop it down to the next number, which would be even. So in other words, what you do is you say, hey, I've got the square root of x to the 5th. That's really square root of x to the 4th times x to the 1st. 4 and 1 gives you 5. Square root of x to the 4th, cut that in half. Plus or minus x squared, but then that 1 is still left under the radical. So x to the 5th becomes this. That's what happens if it's odd. Whereas if it's even, x to the 6th, that would just be plus or minus x to the 3rd. And that's why we call it the SOX method, because you have to pair your SOX. You have to pair your SOX. So check it out. We know the square root of 81. I like to split this into the number and the variable. Square root of 81, that's nice and simple, plus or minus 9. Now, x to the 8th, if you have 8 SOX, how many pairs can you make? If you have 8 SOX, how many pairs can you make? Oh, that would be 4 pairs of SOX. Cut it in half. Boom. Check it out over here, though. Square root of 16x to the 17th. We know we're going to split it. Square root of 16, that's very easily plus or minus 4. But if you have 7 SOX, how many pairs? How many pairs can you make? You can make 3 pairs, but you have 1 SOC left over. 3 pairs with 1 left over. That's what I mean by the SOX method. I like to use that to help me out anytime I'm dealing with an odd exponent. 3 pairs, 1 left over. So let's do 1 together, and then I'm going to let you guys try 2 and 3. Check out number 1 here. So, 150. A little bit of a bigger number. Let's split this. Okay. Biggest number that's going to go into 150. We start big. It's not going to be 144, not going to be 121, not going to be 100, not going to be 81, not going to be 64, not going to be 49, 36 doesn't. 25. That definitely is going to work. And so this is really, let's see, 150, that'd be 6. And we know really that the square root of 25, you can kind of skip the middle step if you want to. That'd be plus or minus 5 with a square root of 6. I'm sorry. Plus or minus 5 times the square root of 6. But then over here, 6 SOX. That would give you a to the 3rd, 3 pairs. 8 SOX, that give you 4 pairs. And that's just c to the 1st. If you just have 1 SOC, we can't make any pairs. And so how we write this, guys, is you put everything not under exponents up front. So plus or minus 5, a to the 3rd, b to the 4th, and then in the back end, take what's still under the radicals, put it together. And that would be your answer. A little bit tricky, I know, but it can be a little bit tough to simplify these sometimes. Really, the toughest part for me is sometimes finding the perfect square that goes into it. So I'm going to let you guys try 2 and 3. And then once you've had a chance to try it, we'll just have 1 page left, and I'm thinking I'm going to make a short 3rd video to knock out that last page. That way you guys can pace yourselves. So try 2 and 3 for me. You can pause the video. Let's see how you guys did. So number 2, I'm going to split this into its 2 pieces. We know these are being multiplied, which is how they're still connected. They still multiply to give us that. Square root of 72, the biggest perfect square to go into that would be 36. 36 goes into 72 2 times. Square root of 36 would, of course, be plus or minus 6. Meanwhile, over here, if you have 6 pairs of socks, or if you have 6 socks, that makes 3 pairs. You have 3 socks, that makes 1 pair with 1 left over. And if you have 2 socks, that makes 1 pair. So then we take everything outside of the square roots, 6, a to the third, b to the first, c to the first, and then we take everything still stuck in square roots, 2 and b, put it together at the end, and you have your answer there. Number 3, very similar. Split it. 9 goes into 45. That's our perfect square, just like 36 was. And so we know that 9 will become 3. 2 socks become 1 pair. 5 socks becomes 2 pairs with 1 left over. And 8 socks becomes 4 pairs perfectly. So then you take the 3, the x, the y squared, and the z to the 4th, put those out front, and then combine the 5 still stuck in the radical and the y. So our answer would be plus or minus 3x y squared z to the 4th times the radical of 5y. All this, of course, is being multiplied together. Okay, that'll be the end of video 2. Time for part 3. Last thing,